Here's problem 423. Newton approximated motion in a circle as a series of linear motions, as in the polygon below. If we assume the particle moves at constant speed VA from A to B and at constant speed VB from B to C, the direction of the change in velocity at point B is shown by the arrow in. Well, let's imagine if we're going from A to B, we'd be going along this line right here. And so that would be our velocity A. And then if we were going from B to C, we'd be going along this line. And that would be our velocity B. So in a sense, if we put them end to end, we would have a velocity A going like this and a velocity B going like this. So our change in velocity would be this one. In other words, we could think of this as being the velocity of A in a vector sense plus our change in velocity in a vector sense is equal to our velocity of B. So what we started with plus our change in velocity in a vector sense equals what we end with. We add them tip to tail to get to our final velocity. Or equivalently, we can also think of it this way. Our change in velocity should be equal to our final velocity, B, minus our initial velocity, which is A in this case. Now if we did that, what would we get? Well, here's our final velocity, like this. That's velocity of B. And to subtract a VA is to add a vector that is in same magnitude but 180 degrees opposite direction. So our minus VA would be a vector that looked like that. And hence, our change in velocity is this vector here. So our change in velocity is VB minus VA. Final minus initial, and either way we look at it, we end up with a vector that is going in that direction, and we answer C then for our change in velocity.